Hello everyone, my name is Navakanesh and Batmanathan and I am a PhD candidate at University Science Malaysia. The title of my poster is Evidence of Active Structure and its Linkage to Earthquake Events in Northwest Borneo, Southeast Asia. So I'll begin now. So for over the years, Northwest Borneo have been experiencing low to medium magnitude earthquakes. And this includes the 4th June 2015 earthquake in which we lost some precious lives and it caused destruction to both life and properties. And this particular earthquake surprised many people at large, including geoscientists. Why? Because it occurred in an area which is away from all these active plate boundaries. And the occurrence of earthquakes in this region reflects major structures, particularly in Northwest Borneo. And from the evidence from satellite images such as Global DEM and Google Maps, it shows the expression of both minor and major faults on topography and its association with recent earthquake events. Our geomorphic analysis reveals a number of active normal faults, especially on the southern part of the Mount Kinabalu region. As you can see from the figure here, I have prepared a stream network map of the southern region, and most of the earthquake appears to occur on the upstream region where most of the geomorphic analysis was carried out. And we have prepared a longitudinal profile, SL index and nick points, and we found quite a number of nick points along this upstream region which could be related to the earthquake event. And we also did some comparison. These nick points are actually not related to bedding and more to they are more consistent with faulting events. And we have carried out a field survey along this region and found the evidence of northwest and southeast dipping faults, which appears to correlate with our results, our geomorphic results. And it appears that this 4th June 2015 earthquake could be related to both instrumental and historical seismicity in Northwest Borneo, and the discovery of large-scale landslides and old normal faults provides a possibility that this could have reactivated ancient fault lines. And the most important thing, the 4th June 2015 earthquake, during the earthquake we did not see any ruptures, any surface rupture, and this actually concludes the evidence of blind faults. But the cause of this earthquake remains uncertain. A large number of geological studies have extensively shown that this could be related to far-field stresses, gravity collapse, mental processes, and but the exact cause still remains uncertain. And based on our research, we believe that it could be related to an oblique compression. Here's a model which is we have already published this paper, and yeah, I'll move on to the intraplate earthquakes in Northwest Borneo. Most of the fault system in Northwest Borneo have been reactivated due to present day forces, and surface rupture is not observed, and but we have reported a number of old faults, and most of it we found during our field survey. And the 2015 earthquake actually ruptured a fault which has a northeast-southwest trending and at a 12.3 kilometer depth. And this can be, we can actually correlate this to a much recent event which occurred on 8 March 2018 and which jolted magnitude 5.2 earthquake. This particular 5.2 earthquake could have occurred on the same fault as 5th June 2015 or could be related to a southeast dipping normal fault, which could be a different fault. So we have here two models. The one on the left is the 4th June, which hosted on a northwest dipping normal fault, and the 8th March, which probably could have occurred on a southeast dipping normal fault. But what I can say is that it most probably happened on the same fault as the 4th June 2015. And all these earthquakes in northwest Borneo actually reflects there is a major major structure in this region, and these areas are based on this field survey and geomorphic analysis. We can say that it's mostly dominated by northwest southeast extension, and we can prove it even from the focal plane solution provided by the USGS. It clearly shows there is an evidence of extension, but the cause of extension remains uncertain. However, through our recent publication, through our recent work, we actually conclude that the extension in Kundasang and Ranau region where the earthquake occurred strongly backs a tectonic origin and is probably responsible for all the intraplate earthquakes in northwest Borneo. And as I've mentioned earlier, we have prepared a model, and here's the oblique compression model. We believe that this intraplate deformation is controlled at depth by a major strike slip, a major sinistral strike slip fault, which runs from all the way from southern Borneo to all the way to the north Borneo. It's roughly about 900 kilometer long fault. And based on all this, we can actually see there is there's more explanation to these events. I mean, the previous studies have mentioned a lot of far field stresses, gravity collapse, and mental processes, but now we are proposing an oblique compression model which could actually represent a new evidence for this area and possibly explain all the current tectonic processes. And that's all from me. Thank you.